Welcome to another episode of Code for Thought. This episode takes us back to Imperial College in London in the UK. In July this year, 2024, I made my way to Imperial College to meet with a group of 6 PhD students and postdocs working in different fields, ranging from material sciences to wet labs to medical research and computer science. What they all had in common was this: they were all selected by the college to champion research software in their departments and faculties. And this is the story about how the championship went for them. But before you hear from our champions, I'd like to set the scene and put the Research Software Championship at Imperial College into a wider context. Since 2012, the year when the term research software engineering was created in the UK, we've seen a growing number of universities and research centres in and outside the UK building research software engineering teams. Some of the teams have become quite large, in fact. For instance, when I joined the RSE team at University College in London in 2019, the team already stood at 18 members. But when I left in June 2023, the headcount was already close to 50. Other universities in the UK and around the globe see a similar trend. But even the growing number of research software engineers cannot make up for the ever-growing demand on software in research and the sheer volume of research projects in a country like the UK alone. To put this into numbers, the Society of Research Software Engineers in the UK has about 700 members, and the Slack channel of the society has a wider reach, which I believe close to 5,000 registered users. On the other hand, the number of researchers, including PhD students and postdocs, is of course a lot higher. If we look at the number of PhD students, for example, in the year 2020 to 21, there were over 100,000 students enrolled in doctoral programs and circa 21,000 of whom graduated as PhDs. So perhaps you can appreciate that the services research software engineers can offer can only be limited, and at the end of the day is still a drop in the ocean, and likely to remain so in future. Which is in fact why a lot of the software in research is in fact written by PhD students and researchers themselves, and sometimes by people with little or no experience in software engineering. And for that reason, it's important to help researchers become better at writing code. And this is indeed one of the goals of the championship at Imperial. The application form for the 2024 cohort of champions, that is this year's cohort, bears the title Inspire and Train Your Peers to Write Better Research Software and Promote Their Work. The championship scheme, which is funded by Research England, runs for a fixed period of a few months, during which champions are expected to advocate for good quality research software in general and provide at least 2 interactive community sessions specifically. When I met the champions in July this year, the current scheme was nearing its end. And in fact, this was the second cohort Imperial has been running, with the first one completed at the end of 2023. Which brings me back to the 6 PhD students and postdocs who answered the call to become software champions. Meet Xavier, Benjamin Scharpf, Lukas Kopecky, Jakub Lala, Sara, Patti, and Sneha. And here they introduce themselves. First we hear from Alan and Ben.
My name is Xavier. I'm a PhD student in the Mechanical Engineering Department at Imperial College. My current research focus is actually in developing machine learning algorithm for CFD simulations with the aim of accelerating these CFD simulations for industry and academic use.
I don't quite understand what that is. What kind of simulations?
So CFD is computational fluid dynamics.
Oh, right,
so in many applications we see a lot of high-scale fluid flow, especially in turbines, where we have planes, we have high-spinning turbines and air flowing through it, and those fluid flows are governed by the Navier-Stokes equations, and we normally simulate them using numerical simulations.
Right, yeah, hence the computing.
Yeah, hence the computing, which are quite time-intensive. and require a lot of computational resources in order to solve these unsteady flows. So that's why we're looking at seeing if we could use machine learning to help speed up the time at which we can solve these flow simulations.
Ben, the next champion, actually works as a research software engineer, as he explains now.
So I'm Benjamin, and I've been a postgraduate research student here at Imperial College London in the Department of Computing, where I've spent a decent amount of time. And at the moment, I am working as a research software engineer and in the high-performance computing team.
So you actually are a research software engineer then?
Yes, exactly.
So you work in high-performance computing
Well,
in a particular area?
Yeah,
or?
it's located within both teams. So we have research software engineering, which considers problems within writing efficient software or refactoring software or productionizing software. And we are helping researchers to employ software engineering techniques in order to make their computations more efficient or to publish specific packages.
Yeah.
And then there's the angle, another angle, which is programs that need a lot of data or sophisticated hardware, and we are then running them on specific machines. So these are high-performance computing clusters which have specific needs. So, for example, if you want to parallelize a specific computation across multiple nodes, potentially hundreds or thousands of nodes, then a local machine is not sufficient anymore, and then we run them on specific clusters.
Our next champions, Lukas and Jakub, both in their ways work in life sciences. First here's Lukas, and then followed by Jakub.
My name is Lukas, and I am a second-year PhD student at the Department of Metabolism, Digestion and Reproduction. And for the past couple of months, I was also working as the Research Software Champion, which is a scheme that to promote good coding and good software development practices within Imperial Research. And my background is originally in computer science. So
computer science?
Yes. And my research area is rather exciting because it's health data science, bioinformatics, and in analyzing and metabolomics data. So it's quite exciting because it meets the area where computer science meets systems biology and chemistry.
Right. And now over to Jakub.
So I'm Jakub. I am a year one PhD student at Imperial College in the materials department. My PhD project is on RNA structure prediction using computational methods, biomolecular modeling. Also wanted to put some machine learning in there. I have a background in materials, but now I'm sort of trying to transition more into the AI in biotech space.
And now we've come to the final two champions, and I'd like you to meet Sara and Sneha. First we hear from Sara.
So my name is Sara. So I'm a PhD student in the National Institute of Heart and Lung at Imperial College London. My background is predominantly wet lab. So I did my master's in immunology, and then I worked in early drug discovery for 3.5 years before joining Imperial as part of the multi-sci MRC DTP. And in the first year of that, we do an MRes. So I did an MRes in data science, and now my PhD project is focusing on spatial transcriptomics, image mass cytometry, so sort of multi-omic studies. And so that's where more the computational side is coming in, and been a lot more interested in the bioinformatic approaches that we can use to analyze those sorts of data sets.
When you say wet lab, is that a clinic, a hospital, or is that sort of pure research?
So it's any kind of laboratory work that you're working with cells or proteins or sort of on the bench, as opposed to dry lab being more computational work, so things that you would do on a computer. So historically, I would say take blood from a patient, isolate the immune cells, and then I would be doing different experiments where I'm, say, knocking out a gene, treating with a certain drug or other sort of activators to initiate or induce some sort of response that we're interested in, and then looking at how, if we make changes to the environment, how that then will change the function of our cells.
And now, and finally, Sneha, who actually was part of the very first Champions cohort in 2023.
My name is Sneha. I'm a postgraduate researcher at Imperial College London, and I work across the Department of Maths and the Department of Surgery and Cancer. My experience is in computer science mostly, and currently I work on machine learning research applied to healthcare specifically.
What I found interesting is that Sneha had actually a previous career in the private sector, which is what she tells us now.
In my past life, I have been a full-time software developer, which does seem like a long, long time ago, to be honest. And since then, I've worked in the US as a hands-on machine learning researcher, and then for the past 4 years in the UK, working at Imperial.
Well, Sneha wasn't alone in coming from the private sector. Ben also worked as a software engineer in the industry before joining Imperial.
Actually, I was working in industry before I came back to
Where?
academia, at a financial broker in the city of London.
Oh, well, all right.
Yeah, so you asked me about what my background is or what I've been researching on, and actually I'm very much interested in computational finance, algorithmic trading,
Right.
and limit order books, like electronic financial markets. There's plenty of markets that are where computers trade with each other, others rather than humans. My particular area was stock markets. There's many more. There's futures. There's derivatives markets. There's also fixed income markets or forex markets that trade automatically. My particular domain was stock markets, equity markets,
Okay.
and I have been working in the quantitative finance industry for a few years.
And now that you've met our champions, let's turn to the question what role software plays in their respective fields. If there's a common thread in all of champions I talk to, I would say it's the use of machine learning techniques or their wish to get into it. But of course the type of software being used, whether it involves machine learning or not, depends on the field it's being applied to. And this leaves us quite a wide range of different apps with different levels of complexity. For example, Xavier already gave us a flavor of what kind of software applications he's dealing with in the Department of Mechanical Engineering, which has to do with computational fluid dynamics. And I also want to highlight two other and very different examples. One is from Jakub. In the introduction he mentioned having a background in material science but actually doing research in biotech. And that quite frankly intrigued me, and I wanted to know from him where the overlap between the two is and how software comes into all of it. So here's Jakub again. Materials is usually something that we don't necessarily associate with biotech or life sciences?
Right, so that's a good point. The reason why I am like more on the bio side is specifically because of my supervisor, because he's really now interested in protein design and all of these new tools that are coming up. He also has a company spinning out that sort of uses computational materials method for soft matter, which is polymers and nanoparticles, but he's more applying it on the biophysical side of actually creating delivery systems for drugs. Generally, materials is quite a broad term, and it lives like in between physics, chemistry, and biology. This flexibility is awesome because you get to do whatever. And throughout my undergrad, which I've done in the same department, I was able to explore all these things and find my niche. But at the same time, it gets quite confusing, and people have to be quite versed in a versatile of different sort of fields.
Yeah, okay. Where does software come in?
So I would say there's probably like two sides of it. One of the sides is experimentalists that need to perform specific data analyses. I would say a large part of what experimentalists need in terms of software is advanced imaging analysis techniques, because a lot of things in materials are dependent on, let's say, scanning electron micrography. And all of these imaging techniques, that goes like through several length scales, right? So at some level, you're trying to look at the grains within metals, and you're trying to look at grain boundaries and so forth. But then you might also want to go, let's say, nanometer level when you're dealing with nanoparticles, and suddenly you cannot use normal visual microscopes, and you need something like an electron microscope. So I think this is like, for example, a large part with what experimentalists would need. But then on the other side, of course, there's this entire computational world. And I think that molecular dynamics, for example, or different ways of simulating materials, going from simple molecules and using, for example, quantum chemistry methods, for instance, with density functional theory, but then all the way to something like simulating proteins, where you actually run some molecular dynamics. This entire sort of length scale has been explored for the past 50 years.
Sara also works in life sciences, but in a very different environment. And here she gives us an idea of the kind of software and data analysis relevant to her field.
Historically, when we were looking at, say, a protein of interest, we could only look at one. But now with these new technologies, we can look at hundreds or thousands at a given time. And so the traditional methods, statistical methods that we were using, say on, what wet lab biologists would typically use is like PRISM, where you can analyze and run statistical tests on a small number of comparisons. When you are generating these huge data sets with hundreds of potentially thousands of features for every sample, you can't use the same traditional approaches to analyze the data. So that's where the computational computational work comes in. So typically using either R or Python to analyze these big data sets. And there's a variety of different pipelines that are publicly available that have been created by different either academic institutes or groups across the globe that you can then leverage to actually analyze these data sets. So for me, I would use publicly available pipelines to say do a single cell RNA-seq analysis. And so you wouldn't be able to do those sorts of high plex or high number of feature analysis without the computational tools that have been currently available. And as more and more tools are created, you can get higher resolution or more information out of the data that you've already generated. And there's more and more kind of wet lab approaches. So something like spatial transcriptomics, where you get not only the transcript of a cell, but you can see where it is spatially within a tissue. So there's more and more pipelines that are coming up to analyze those sorts of data. So as the kind of data that becomes more complex, we need more complex pipelines to actually analyze and try to extract as much information we can out of those data sets. And so that isn't possible without the sort of computational resources or bioinformatic or computational biology approaches and pipelines that have been generated.
Now that we've got a flavor of the kind of different software our champions use, let's turn to the question of what made Alan, Ben, Lukas, Jakub, Sara and Sneha join the championship, and what did they do during the time. And with such a diverse group of champions, all working in different research areas, you'd expect the reasons for joining the program and running it to be just as diverse, and you'd be right. Of the people I talked to, Ben is in a somewhat unique position, in that he already works as a research software engineer focusing on high-performance computing. His experience in finance and the private sector were contributing factors to why he joined the program, as he explains in the following conversation.
What made you actually join then?
That was sourced out of multiple reasons. When I then worked in industry, I noted what things are not done right, or what things can be improved. It was quite frustrated to see that software that is not tested properly breaks quite easily, or if libraries or code reviews or the so-called CI/CD pipeline, so continuous integration, continuous development, is not facilitated with enough rigor. Things break and break predictably. So that was quite frustrating. So when I received an email from one of my former, I think, course administrators, actually, Amani, so I thought, okay, I have this invitation for applications. I have some knowledge in the academic landscape and I have some experience in the practical landscape. So let's combine this, send an application out and see where things go. And then I received an email telling me that I was accepted to the scheme. So I've been working in this role for the past 3 months.
So what have you been doing then?
Unsurprisingly, I cannot really shake off the financial data science part.
Okay.
So I was working on design patterns for financial data science. That's my project, or that's the title of the project.
Design patterns in general is not just for financial applications and markets. So design patterns, as you could use them in various different research areas.
Exactly. In any sort of software that is meant to be reproducible, that is meant to be efficient, that is meant to be readable, and that is meant to be factored into clear components.
That's quite interesting because design patterns can be quite abstract and can be, at least when I came across them during my time as software engineer, at first not intimidating, but could be a little bit above your head. Is that your experience as well when you confront people, not confront, but let them know design patterns, that it's difficult for them to understand what the purpose of them are and why they should be using them and what they're there for in the first place?
Yeah, that's indeed the case. Obviously, we will appreciate their being once you encountered particular pain points during your practical experience. But then you think, okay, has there been any work done? Is there a better way of doing things? Has there been a book published or an article published that addresses these issues? And yes, there has. The book is, I think it's about 30 years old by now.
Gang of Four, you mean?
It's a classical Gang of Four books. And as you rightly point out, it's very abstract and it's not a book that you read from cover to cover, and it's certainly also not bedtime reading, but you can borrow the ideas from it and to re-implement them.
As I alluded to in my conversation with Ben just now, design patterns are rather advanced topics when it comes to software engineering. And I found it quite interesting that Ben has been driving the use of design patterns as part of his championship. But then you have to remember that Ben works in the RSE group at Imperial and in high-performance computing, where you might expect a more advanced skill level and knowledge of engineering practices. And in that respect, Ben's experience is markedly different to, say, Sneha's. And as I mentioned before, Sneha actually completed her championship as part of the first cohort in 2023, and here she talks about her experiences when moving from the private sector into a clinical environment.
And it was the first time that I was working directly with clinical collaborators in the Faculty of Medicine. For me, it was also the first time that I was surrounded by people not with backgrounds in computer science all their lives. I think it caused me to learn a whole shift in my vocabulary. And that's a process that has been going on for me in the past 4 years, and it's been a massive learning experience. It's brought a lot of other small changes in terms of what you expect in terms of computing resources, what kind of general literacy around certain modeling and statistical techniques you expect, and what kind of day-to-day discussions you have in and around your office, really.
Is that the reason why you applied for becoming a champion?
It was definitely one of the reasons. The primary reason is that I do like to program hands-on, even in my own research. And the interdisciplinary work that I do with the Faculty of Medicine now, it requires me to think of problems and think of ways of implementing that problems in different ways at the moment. And it's been a different kind of experience trying to talk to collaborators who are not programmers in their day-to-day lives or don't have the need to do the kind of work that I do. So being the research software champion for Faculty of Medicine in particular, I think was a unique experience. I feel pretty safe in saying I'm sure the other software champions didn't have the kind of experience I did.
That piques my curiosity, because I think you were part of the first cohort actually last year, which
Yes.
wasn't that? Yeah, indeed. So what was the kind of experience that you think were unique?
I think the very first thing was, I'm not sure anybody else was fielding questions like, what the hell are you talking about? So the people that I reached out to, it was like selling something to people. And even before you try to sell the thing, you try to tell them why they need it in the first place. I started with my immediate collaborators, and they, by virtue of having worked with me, were a lot more sympathetic, and it was much easier for me to bring them up to speed about what we're talking about, what is research software really. I also realized that Faculty of Medicine is in itself a very, very diverse group. People work on a wide variety of research, a very tiny part of which I'm even aware of, really. People mean very different things when they even think coding or programming. So I can use terminology, like even very basic terminology, and it would be picked up much more quickly with other collaborators or people with computer science background. Or even when they do recognize certain terminology, it just means different things to them, or it brings up different levels of complexity in their mind. Things like version control, it's something that people may have heard of, but have no idea or no real desire even to know why would I even want to know about. And you have to remember, these are people who are very busy and experts in their own field, and it's very hard to ask people to devote time to something that they don't recognize the need for right off the bat.
Jakub or Jakub gives us yet another flavor of how he used the championship to help his colleagues using good engineering practices. And I would sort of describe Jakub's approach somewhere between Sneha's and Ben's, but let's hear from him himself. What is it that you then focus on during your championship?
Generally, what we have going into the championship scheme, we're trying to think of like what is the most impactful thing that we can do in the department. And from the general consensus of what we've talked about among the champion colleagues is that people do not develop software, let's say, reliably and like scalably and reproducibly, and they usually have random Python scripts lying around. This entire idea was like, how can we bring about software practices from industry, for instance, to the people in academia? For me specifically, I ran a workshop where I try to get as many people into the same room and tell them about all of these amazing events or workshops that the college is running, where they would give you 3 hours where they teach you about GitHub. I think one like learning outcome that I've got from this is that there's some extra work that you have to do when you're trying to do things scalably and reliably. And in academia, there's not a clear incentive to do so, especially when you're doing research and when you do not know whether that code will ever get published or will be public. And so I think there's this important nuance of and trade-off of how to really employ these practices in such an environment.
To help researchers adopt better software practices is a bit like an uphill battle, as I think many of us know. And as Jakub just said, researchers are busy people with little time, or as is the case in Sneha's environment, with no or very little prior knowledge of basic concepts of software engineering, or even the language we use. But you have to start somewhere. And despite all the different work and research environments and circumstances, there was quite some overlap in the areas the champions focused on. And they included the need for software testing and, even less surprising, version control with Git and GitHub. And in the next section, I'm going to talk a bit more about how the guys try to champion better software practices in their departments and faculties, and how they think it all went. The championship at Imperial came with only few requirements. Champions were expected to run 2 interactive community sessions, the content of which, however, was left to the champions, as was the way in which they used their time to advocate for better practices. So let's start focusing on the interactive sessions or workshops. Workshops have, of course, the benefit of bringing people together and have them share know-how and experiences. All the more so when they are coming from different departments to cross their silos, as Ben puts it in the following clip.
How did you then go about in your role as a champion to tell people about or teach people about these patterns?
There's various ways of communicating. Obviously, again, in academia, but that's let's say, an inherent problem. We tend to operate in silos. So that means we have, let's say, the Department of Computing, and within the Department of Computing, there's people who do, let's say, who work on compilers.
Yeah.
They might not encounter design patterns at all, but then there's people who write software professionally who do care, PhD students who do care. There is the business school. They use the classical Jupyter notebooks, and they would, I would say, they would benefit quite greatly from design patterns. The thing is, just, do the students or do the researchers have enough time? But one key point in advertising about them was during a conference, or let's say it was more like a research workshop, that was also part of the champion scheme. It was organized within the Beyond Open Research community, and there were, I think, 4 of these conferences, and I was invited to the first. I was able to speak to other researchers from other departments, medical sciences, chemistry, about the benefits of them.
And as Sneha mentioned before, sometimes you really have to dig in and cover the basics before you can reach such lofty heights as software design patterns. This was also the experience of Sara, who, as she told us earlier, works in wet labs. So here's Sara.
What did you hope to achieve then as a champion?
I was really hoping to help people who work in the biology field or in traditionally wet lab understand that you can get into the sort of computational approaches and you don't have to be as afraid of them as they sort of seem. So there's a lot of terminology that's commonly used by computer scientists that is sort of taken for granted that the average biologist has no idea what you're talking about. So for the workshops that I ran 3 of them. It was sort of an introduction to basic terminology. So thinking about, for us, we know what Git or GitHub is, but if you're a wet lab biology, if you've never heard of it, you'd maybe don't exactly know what a bioinformatician does versus a computational biologist, or even what a developer does, or a software engineer, like what those sort of words mean, or like when I say pipeline, like what does it actually entail, or talking about what is R versus what is Visual Studio Code, what is Python, when do you use Visual Studio Code, what is a Jupyter Notebook, why do you use like R as a computer language versus RStudio as an IDE. So those sorts of terminologies that I think a lot of people in the computational world take for granted as not being something that they need to explain. And then also talking about if you do start getting into coding, not only, you obviously need to learn how to code, but there are certain ways you should structure your code, things to make your life easier, to make your code more reproducible. So thinking about setting a seed, because there's a level of randomness in a lot of the algorithms or statistical packages or different pipelines that they might use.
I really like the idea of running a jargon-busting workshop and help demystify software engineering and what it is that engineers do. But sometimes workshops aren't enough, and what you need are one-to-one sessions. And this, of course, was a large part of what our champions did outside workshops and community events. Sneha, for example, who like Sara works with people with little software backgrounds, set up coding clinics to help them with specific problems and questions around software.
We ended up doing coding clinics with the people in the faculty where they could discuss one-on-one specific problems that they had in terms of software. Things like, I brought up version control, and my philosophy around these things always is that they might not understand what exactly is the problem of version control in those terms. But once you start to talk in terms of problems that they do face in their research, when you start to remind them of how many file v1.0 and file v3 they have had to write, the night before their submission, I think it starts to show them the areas where the research software does come in. And I think it's very delightful to see people realize that these are things that other fields or software engineers have thought about and dealt with, and it might not be as complicated as it is in their minds.
And Lukas also used the combination of workshop and coding clinics to advocate for better software practices, as he explains here.
I was trying to support some of those in sort of one-to-one session to solve something with coding or other things like that. And also I run a workshop which was focused on version control and how to use Git and GitHub so they can cooperate with others more effectively.
All of the people that I talked to spend a considerable amount of their time on the championship. In fact, Imperial stated in the application form that they expect champions to spend about 50 hours in total during their time. And though the aim was to raise the awareness of software engineering practices, such as testing, the use of version control, or even design patterns, the champion scheme also helped the champions themselves, as we will hear in the final part of this episode. Well, as I said before, when I met with the champions in July 2024, they were all reaching the end of their championship, which was a good moment for them to think how it all went for them and what it was they got out for it for themselves. They all agreed that one of the major benefits for the scheme was that they were able to meet other people, make connections, and grow their network across the college. Sneha makes this quite clear at the end of my conversation with her.
A lot of it was mostly increasing my own exposure within my department. I think for me personally, that was a very useful thing that came out of the program for me. I was a not so usual computer scientist background person in my department. And like I said, I came during the pandemic and there wasn't a lot of interaction between researchers happening at that point. And the RSE program was really a good way for me to interact with people in the department that I hadn't had a chance to before. And so, like I said, a lot of the informal interactions have continued. I've also stayed in touch with the RSE group at Imperial. Last year, I gave a talk around large language models at the annual Christmas party, and it was a very nice interactive experience to, again, meet people from different departments, even across other universities in London. And some of that has continued with people at UCL, for example. I think it's still happening.
Alan was another champion who thought the networking opportunities during his championship were one of the major positive outcomes.
I got a lot of opportunities to network with a wider community of research software engineers, and I got to meet a lot of fantastic people through the department, which I hope to keep my connections going forward.
But networking wasn't the only benefit from the championship. It also provided a chance to get a deeper understanding and more hands-on experience with software engineering practices, which is what Sara tells us here.
So for me, it was a really great opportunity to reinforce the sort of topics that I thought I knew. But when you have to teach them to someone else, there's a lot more information, I think, that you end up realizing that you don't have or understanding that you potentially lack. So for me, trying to go through what I found really helpful when I first got into the field, but also the kind of gaps that no one taught me and no one explained to me, and then being able to put those into a workshop and then trying to figure out how do I explain that to somebody else. So I learned a lot from the experience, and it reinforced knowledge that I kind of thought I had, but I didn't probably understand as deeply as I needed to or had wanted to.
And finally, let's hear from Jakub, or Jacob, who summed up nicely what he got out of it.
I mean, it's been an exciting journey overall. I met Jeremy and the research software engineering team, and even I had like one conversation during that workshop that like made me do something in my own research, just switch, because I was spending like 2 weeks trying to compile the C++ library. And then during that workshop, I was talking to Diego, who was on the research software engineering team, and he just told me that like just use Python when you're prototyping. And then I switched to Python, and like actually it made so much more sense to do that. So all of these connections were very nice, and I'm grateful to be a part of that. In terms of the actual like curriculum or like content that we've done, although like it was exciting to meet all these people, even from my department, which sometimes is not that easy to do since, I would say maybe since COVID, that was actually the learning outcome, is that it's hard getting people into a single room and trying to teach them or trying to get them excited about certain topics, especially in the materials department, where there's not a single narrative, as I said at the start, and materials is kind of ambiguous in how it is defined. Even in that workshop, where my goal was to sort of understand what people need, out of 10 people, like each of them had extremely different needs. And there was one person that needed to create a Python UI interface. But then there's folks that using Julia, and they're quite versed in version control and all of these advanced techniques, and they clearly do not need anything more. Or there's people that want to learn Python. They have never done Python. So there's these very different needs. And I found it quite difficult to streamline that.
Research is a rather transient field. With each year, you get a new generation of PhD and master students and postdocs, and once you've finished working with one group of researchers, in comes the next one. Promoting better research software is, to quote a software tutor I once met, a gift that keeps on giving. It can also be, as Jacob just said, at times frustrating. So when it comes to championing better software, better research, we're really in for the long haul. And this is something I think all champions realize. Some of them intend to continue at least some of the advocacy work they started during the championship, but then of course, being PhD students and postdocs themselves, they need to get back to the research. Which makes me hope that a program like this continues, and not only at Imperial, but across other universities and research centres. And later this season, we'll come back to championing research software, and in particular talk to the organisers at Imperial College and look at what's been happening in other universities or research centres. So stay tuned. Finally, before leaving, I'd like to thank Imperial College for giving access and indeed supporting the production of this episode. If you would like to support this podcast, get in touch or go to my Patreon page. Thanks a million for listening. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.